Greetings, Earthlings. Okay, so here what we have today is an Airlift, kind of a hybrid Airlift Geyser pump. And what it is it's a 2-inch diameter PVC pipe. On the outside, this is your geyser chamber actually. On the inside is a 1-inch PVC pipe that runs down. It's a 5-foot pipe, 2-inch diameter, 5-foot pipe. PVC, and on the inside is a 4-foot long 1-inch diameter pipe where it's got an elbow attached on the inside of it, a little 3/8 inch elbow for an air line that goes on the inside, and that runs up to this tube over here, which is teed. It's teed into this thing over here. We've got a T here, so this is your air inline input running over to a T that goes down in here to right here, attaches into the 1-inch pipe, and what that does is it bubbles and it lightens the water column. I have a 1-inch riser pipe that goes out of the well, and then the other air line comes through here, and it just comes in about 1 inch into the top of the chamber, and that goes on the inside of the 2-inch pipe, but on the outside of the 1-inch diameter pipe, the air level is now coming down here, all the way down. And as it gets to the bottom, it pushes on the water column of the well, and it hammers up. The little emiscus line will hammer. I'll show you that in another video, but it's just a hammering, like a valve action like this, and pushing up water. Well, bubbling makes the water column lighter, and this huge air bubble is created and goes down in there, then fills up and jets up the water column. And so it's an Airlift pump. And it's about $50 in PVC parts and hardware, and that is designed to replace some of my other stuff here. In here we have a 2,500 gallon holding tank, and that has a foot valve in the bottom which sucks up water, and it goes into one of my Harbor Freight $79 pumps over there. Those are two that are previously used. They're pretty much cheapy little pumps from China, but they're broken. One has a bad motor, the other has a bad pump, and those two over there are waiting to be cannibalized into one good backup. And I'm using this Airlift pump to get away from submersible pumps and motors and things that require a little bit too much maintenance inside the well shaft. You get crud in there, and these are actually very good for cleaning out your well. When you have a pump, everything from DC motors that suck up water, suction line type thing, to submersible pumps, there's always maintenance involved. They're always breaking, and it's nice to just be able to bubble in air at a very efficient rate. These are actually very efficient as far as energy consumption. I'll show you in a minute here my well with a 90 psi air bubble and about 1 gallon of air put in. It's taking out of my little well, my 3-inch diameter well casing, about 1 gallon every minute. Anywhere from 1 to 5 gallons a minute out of my well, a second, not a minute. So 1 gallon a second to 5 gallons a second is about 60 to 300 gallons a minute flow out of my well for putting in a little bit of air, a bubble from your air compressor. And that'll be next. Okay, and what we're doing right now is we're bailing the well. We've got about 90 psi going into it, and I've got about 9.8 cubic feet a minute coming off my shop compressor, which is running down into this. This is a standard Airlift pump that's, trying to remember what I did the other day on it. I've got a 1-inch riser pipe in there, but nothing's actually going into it. I have over here a 1/2-inch line. So it's basically just a 1/2-inch PVC line with air going down into it at the very bottom of my well. This well is 27 feet deep. It's a shallow well, and you can see we're getting about 1 gallon every second, which is about 60 gallons a minute flow rate out of my well, which most wells hearing for a very skinny 3-inch diameter well pipe, 60 gallons a minute flow is pretty good. That fills up my 2,500 gallon tank pretty quickly. If I were to pump that much air into this well shaft, you get a pretty impressive flow rate, but the problem with that is that you're using a lot of air, a lot of energy. This is taking about 3,400 watts off my compressor to pump that water out of there. So you want to move to a geyser pump, which is more efficient on the air bubbling. You can use like a little aquarium pond pump and just keep filling that chamber very slowly over time and keep spurting water into your tank over a 24-hour period. An aquarium pond pump is about 3 watts. You have maybe 3 to 5 of those, but what's more efficient is actually a blower, a centrifugal blower, and something that puts out a high volume of air but at a fairly low pressure, because you really don't need more than about 20 to 30 psi, and even less, and then you can get by with about 2 cubic feet a minute on the flow rate of air, just to do some work on a pump like this. So I'll show you more. It'll pump, but your frequency and your volume goes down as you lower the air pressure and lower the cubic feet per minute of air going into the well. And a lot of times these are very inefficient as far as the air use to pump up water. You're usually pumping more air than you are water, unless you make the bubbler chamber just nicely with like a hybrid geyser design like I've done on that 2-inch tube out there. And the reason for that is to get rid of this thing. Now this was my Grundfos SQ10 pump. Had it in operation for about 5 years, and a pump like this is about $500 to $900. Some of them are even $1,800. But the problem with this was that it was way over pumping my well. I had to dial it down with a little ball valve here on the old system, and I didn't like it because it's computer controlled. So every now and then, when you get some over cavitation in the system, it would bubble up and it would overheat the pump, and so the pump would start to shut down. You know, you don't like your water shutting off when you want it to take a shower. There's no water, just because the pump got a little cranky. And but it protected it. It made it last in sediment and heavy, intense use for about 5 years before it broke. It should have lasted longer, but we had a lot of intense use on it. And something went out on it, and I didn't feel like paying about $200 to have it repaired. So at that point, I switched over to other cheesy pumps, like this SureFlow here. And this is a typical RV type pump, a trailer pump. This is what's putting water into my 2,500 gallon tank. Right now this is the sucker line that goes into the, I've got a lot of hokey prototyping over there, and that line is the suction line. It's got a foot valve in it, and that foot valve comes into here, sucks into my little SureFlow pump. Now these pumps can run dry and they'll suck up the water. When they're brand new, they really suck up the water from a 20-foot well pretty nicely. Problem is, you get crudding in here that will block off the suction. You get icing in this line by winter time, and you have mostly a brushed motor in here, which really stinks, because with they're not meant for 8 hours a day use or 4 hours a day. Even when you cycle it over on a timer, what I do is I cycle it on and off every 15 minutes to cool it when I'm doing an 8-hour pumping job. But even that will wear this down in a couple months, so you're having to change the brushes. The commutator shaft gets all crudded up with carbon and brush fouling, and so that weakens your pump, and then pretty soon you've got no more suction, no more water going into your house. And a little trickle flow out of a little hose here will I'll show you it here. Get a pretty good little flow, but this amount of flow coming out of my well is pretty wimpy. Right now it's not getting any flow because we're agitating with that water bubble, but it's just a real piss of a flow that's not really even worth bothering with. There you can see a little bit. Well, it pumps better than that, but it's really more like about a half a gallon a minute to 1 gallon a minute. So I don't like these pumps. The pump itself is alright, but the motor stinks. So if you moved over to like a brushless motor, they're very expensive. You could also go with a little RC airplane motor, pretty high torque, lightweight, brushless type motor, and rig it to the pump so you could pump one of these. But I don't like suction and foot valve pumps. I prefer a submersible pump, and I was looking for a better design when I came across the Airlift type pump, which is much better. See, now that's really cleaning out my well right now, and it's just doing a great job. And right now I'm bailing it out mostly to show you it in operation and the flow rate off my well, and then also to clean out anything that got in there. I had the cap off last night, so sometimes frogs and spiders and bugs get in there. I'm also clearing out any sediment at the bottom of the well. As you move that airline deeper, it will start to clean out the well. So right now I'm pretty much sediment clogged to about 20 feet, and I'm going to start bailing out. Before I stick in that tube, I'm going to start bailing out about 7 feet more of just sand and sediment over the years that's been down there, flushing it out. Now here's my brand new Pacific Hydrostar pump from Harbor Freight, and I like it because it's got a pressure tank and a pressure switch and a nice little pump. And when I'm sucking out, this is my suction line. The main thing with these pumps is you never want to run them dry. And the minute they run dry, you don't always ruin the pump, but you will in time the longer you run it dry. So if you have a leak in your system anywhere and it ends up draining your tank, what happened with me was my little SureFlow pump here went out. It wasn't developing suction. We're drawing 2,500 gallons from the tank. Tank went dry. Next thing you know, my pump here burnt out. So we burnt out 2 pumps all at once. But it wasn't that big a deal to replace this one at $79. It doesn't hurt as bad as a $500 to $900 pump. So that's why I like the Pacific Hydrostars, if you can better maintain them. And like this one here was brand new, came from Harbor Freight, and the back of the shroud to the cooling fan was not put on right at the factory. So it seems like they've got kind of a sweatshop labor going on with their pumps. And other than that, the pump is pretty nice, but they don't always last long. You can go with a warranty or not, but when they do break, you can just quickly change them in about 20 minutes. And $79, so it's not that bad compared to $240 or $300 pump. And you get some extra components on there: the pressure switch, the pump, the tank, things like that. I already have a big pressure tank over here from my old system. And then I have just some of my, other pressure switch there. This is no longer in use right now. It's basically a spare part. And then some of these are all sort of prototype components. The prototype for the last 8 years, kind of on and off, running things, testing things, and evolving the system a little better. Over here I have my water filter and my, my sand type filter and my salt, my brine chamber for water softening. This was just a downflowing barrel filter for the livestock, where it was shooting down the water and then upflowing it through gravel, sand, and charcoal. A little bit of field grass in there as a filter. And that gave extremely clean water to the animals, so it was pretty nice. I also use a ozonator rather than chlorine, because my livestock, I don't like putting chlorine into their rumen. And I don't really like chlorine in the system. So we have mostly ozonating, just a little bubble chamber. A $400 unit from, I think that one came from China too, all this stuff on the web. And it's a food grade ozonator, but much higher volume than what you see for a lot of well components. And then, so that's my well. And that's my system there. So next we're going to try testing that 2-inch diameter, 1-inch inner diameter pipe on the hybrid Airlift Geyser pump. And then we'll see how that goes. Okay, now this is the setup that I use to get that about 1 gallon a second flow rate out of my well over here. And what it is just a, 1/2 inch. I had this long line going down. This is my air line, the white PVC, 1/2 inch PVC. I had to cut it short so it would fit inside my skinny well shaft, and made a little elbow turnaround like that. Then it came up here. I just ran in a air line. And this was all stuffed inside the 1-inch riser pipe here. So the reason I had it pushed way up here is to keep the bubbling action from going out the bottom of the well and to actually push it up into my piping tube. So when you use low flow air, I was able to test the ability to suck up water. This was my prototype Airlift pump with bubbling up near the top. And that created a lot of suction and a pretty good flow rate. But anytime you start pushing the air down with too much pressure, it would start to bubble out here. So 90 psi is just jetting out here. The weight of the water column was holding it and trapping it in. The air is flowing down here, bubbling out all that air, and this big bubble that would just shoot things up. So this is actually a very good geyser pump that I made by accident. And that's what it was a geyser pump running into a 3-inch well here. And so it's a nice little geyser pump. And what I'm going to do now is I'm thinking I might I'm going to stuff down, probably cut off a little bit of that riser pipe, or get a 1-incher maybe, and just start blasting water down my air thing. I'm trying to flush up the last 7 feet of it. 7 feet of sediment. So I'm going to do another geyser pump there before I start putting in my airlift pump, and just start sucking up the muck. So that's about it. Okay, now here what we're doing is I'm adding a little safety line in case I've got a break in my pipe. What I'm doing here is if I don't want something to drop down my well shaft, so I'm just drilling a little hole here for a screw to go through and patching it with a little PVC cement. And then that's in case this PVC should break from some of the shock and vibration, and then having this 2-inch pipe drop down my well would be kind of difficult to fish out. I've also secured on the inside the 1-inch PVC. So here I'm going to take a little stainless steel safety wire and run it up to, just wrap it around the screw and then run it up to around my fitting over here, and that will, my 1-inch line, so that will at least keep the unit together. And I'm depending on being able to fish out if ever something should break or this should slip off, fishing it out with the air lines, or being able to blow in air enough to raise the buoyancy to bring the pump back up. If I should break an air line, then pulling it up, the main strength for pulling it up, it's a very lightweight pump, but pulling it in and out of the well is done according to the 1-inch drop pipe. But if that should slip off, you have a second system for filling it until you float it to the top again. And then this is just to keep the components from falling apart inside. The glue is pretty strong, and the epoxy there should not break, but epoxy does sometimes crack and break, and there's a lot of bubbling and agitation going on in here, so I just don't want to have that problem later on. So that's it there. We're going to pop this in a minute. Here's just a quick view of my shamefully ugly stainless steel wire wrap. I just was doing it quick and wasn't thinking when I threw it together, so it's not very good aircraft quality. I'm kind of ashamed as a rocket nerd and aircraft mechanic, but I'll just show you. So here, get it in the sunlight. Here we're just taking a little screw that's been sealed because that goes into the air chamber, so it doesn't have to hold up under terribly high pressure. A little PVC glue, just primer and PVC glue put on it just to hold some air in there. There's not under high pressure. And then you have a little twisty, that's where I started out pretty nice. Then I just ran it up here and looped it around the 1-inch riser pipe to hold it in there, and then an ugly spiral there, just laced it by hand and just wrapping, and so that will prevent any type of dropping of this pipe down the well if there should be a break in the glue, and be able to fish it back up all in one piece. In here I also stuffed a little bit of foam to keep the pipe from banging around a little too much, a little gel foam. This stuff over here, which you normally use for insulation. It's a waterproof gel, so it will tend to hold stuff. That's what I use inside my ram pump for compression cushioning. I'm going to show you a ram pump in a later video if it should work on this thing. I don't know if I'm going to have enough head off that tank to do it, but hopefully it will. So now we're going to drop in the pipe and go from there. Drop in the Airlift hybrid geyser pump. Okay. Okay, so here what we're doing is sort of a dynamic test to make sure everything's okay with the airflow before I drop it down the well shaft. And what I have over here is the connection. So here's the 1-inch riser pipe connection. It's safety wired onto there, a 1-inch pipe. Air is now blowing in here at about 90 psi and 9.8 cubic feet per minute. It's a very high flow rate. Coming in here, that's what I'm doing is just a pressure test. There's really no pressure on the lines, but there is some back pressure. And so I just want to make sure everything's holding up, nothing's clogged, the check valve in the system is working. Okay, so there's my first failure, my dynamic test failure. And that's because I had on here, I had a cheesy little, I have a 1/4 inch check valve going into the system, because that was the only fitting that they had available at the place where I was looking for one. I'm going from 3/8 to 1/4 inch. And so I just wrapped the nub here with a little electrical tape and hose clamped it down, and it fails the test. So before we put it down the well shaft, we got to strengthen that up a little bit. But otherwise, before I had messed with it, it was holding up pretty well under high pressure test. And it was jetting out the air nicely. Everything was here. Nothing else ruptured other than that. So that's the purpose of function testing before you stick things down the well. The other thing is, before you put it down the well shaft, you want to make sure your lines are connected, especially this one here, so you don't lose the thing down your well shaft. And now if this line should break, you want to be able to fish things up. So in fact, I may even just tape around here to make sure we hold that in there. You can always draw it up. So I'm going to put a little tape right here. So it adds, actually zip tie, nylon zip tie, and that will bind these lines to the hose, so in case I do lose the hose, I can still try to pull it up by the air lines. And actually there's one air line in there that's at a 90 degrees, so that would give it a lever action to pull the pump up either way. So a couple little safety changes before we go fully down the well shaft. And I'm going to go turn off my compressor now. Okay, here we are on the second test of the system before dropping the pump down. And what we have is re-secured the airline here with no tape this time, and just straight on the barb with a 3/8 inch airline going into 1/4 there. Nice tight snug fit. I need to get a better adapter than that, but for now it's holding. And that is running at 90 psi up through this white airline, 9.8 cubic feet per minute roughly, as well as my air compressor was rated for 20 years ago. Comes down into the T, goes into both pipes. The noise you're hearing in the background is from my little pump there clicking on and off because someone in the house is using the water. And now this other noise you're hearing is air. Now that's going into my well shaft right there right now and just echoing. And so everything's good here. What I have is zip tied securing over here. So we got the safety wire down here locking it up there in case it breaks. And then I also have zip line wrapping my tubing onto here, and then also up here securing it, so in case this should slip off, it's very tight so it won't slip off, but if it should and drop the pump down the shaft or so, it's still being gripped by the airlines enough where I have a grip here where I can pull the whole unit up by the airline only, provided that part is nice and secure and doesn't break. So we need to make that a little secure later, but right now we're going to go ahead and test it. Right now I'm going to dial down the pressure and start turning it up with the regulator and seeing what we get out of my flow pipe over here. So we're just going to stick this up into the air right here so I can see it from over there gushing. And there it is, my little water spout going upward. And we'll give it a try. Okay, now this is with 90 psi, 9.8 cubic feet per minute flow. I've got the water column starts at 14 feet below the surface, and I have below that I have 7-foot submergence. I only have a 7-foot water column before hitting the bottom there, so 14 plus 7 is the depth of the well. And here you can see that's at the full capacity of my air compressor, which is burning 3,400 watts out of the grid, and it's wasting a lot of air to do it, but when I dial it back, that pulse is a lot less frequent, but you're using less pressure and flow. So this is right now just a full power test of the system, flushing out the well and getting an idea of flow rate, and you can see that's about maybe half a gallon a second, so maybe 1 gallon every 2 seconds, something like that. But there's takes about 3 spurts to make a gallon, so let's see, 1, 2, 3, so 1 gallon every 3 seconds, which is roughly just a rough estimate there. And nice good pressure burst up there, lifting that water column up. Now it's a blower would do this a lot more efficiently, so instead of wasting all that energy on pressure, you just use a low flow, low PSI blower that gives you a lot of volume of the airflow, and jam that down the well, and that will raise my efficiency. But next I'm going to try lowering it down to the minimum and just seeing how far I can dial it down, and that will tell me what's my true minimum PSI it needs and what my minimum cubic feet need is. Right now I'm just estimating it. I don't have my gauges hooked up or anything, and we can put in a little PSI gauge in the line. I don't have a CFM gauge, so it doesn't really matter right now. We're just kind of estimating it. But I'm going to dial it back, and then I'm going to try putting on a little old little portable air compressor I have. It's just the motor only, and see what that will do. And then later on I'm going to decide on the rating to use for a blower. Probably use a blower instead of an aquarium pump, because that would take too long. And just a good, might even try a hair dryer. It's something that pushes air down the shaft is what I'm looking at. And it's just a 3/8 inch line, so the main thing is to go with volume, not pressure on the air. And that will give you volume of water delivered out your shaft. It's very much like a windmill. Turning a windmill, getting the pulsing flow. It's not a steady stream, and you really don't want to put much back pressure on it. Just let it flow freely out the tube. And that is a geyser pump, a hybrid geyser airlift pump. And it's pretty nice. So I'm just going to make it a little more efficient. But the pump is going to stay the same. I'm just going to change the blowing mechanism and the pressure variables going in. Okay, now here I've slowed down the pumping of the air in there, so now we're down to maybe about 10 to 20 psi, and roughly a little bit lower flow. So it's coming out at about a gallon every couple seconds, maybe a gallon every 5 seconds. And still don't like it too well, because I can hear in my well shaft, I can hear some bubbling going on in the water column around the well. So although I'm wasting some air to the water column in here, and I'm also agitating my well, my filter bed down in the gravel pack of the well and the screen, which I don't want to do. I want to keep a nice smooth flow rate. So I'm going to have to, if I want to have it nicer and use less energy with an air compressor, I'm going to have to lower that flow rate a little bit, and or move to a blower. So I'm going to keep dialing it down to the minimum pressure it takes to get my thing flowing. And I've got water flowing, but and better than with my little SureFlow pump. That's much better flow rate, but it's just too much waste of air and too much waste of energy going down there. So we're going to dial it down and be a little more efficient and let it fill up the tank over time. And so we'll see how that goes. Okay, now this is dialed way down to about 5 to 10 psi, very low flow rate, maybe 2 or 3 cubic feet a minute. And I've got a lot less gurgling in my well, so there's just a little bit there, still a little waste. Probably what I could use on here is a foot valve on the bottom, but it would have to be like a 2-inch diameter foot valve, which is pretty expensive. So maybe later I might do that, or I might just live with it, let it clean and scrub the well a little bit. But I don't like it really agitating my filter pack that much. But I'm not sure. I'm thinking about it a little more. But a foot valve on the bottom would keep that wasted air from coming up the column, would make it a lot more efficient, and would still suck in the water, but it wouldn't let any backflow of air or water go out into the well shaft. So a foot valve on the bottom would be good. And then over here, you can see there's still some flow. It's very reduced flow rate now, but it's sufficient to fill a tank over about 8 to 10 hours, 12 hours of not using while you're sleeping, and just letting it keep trickling in there. We can turn up the pressure a little bit, but and it's hardly running my air compressor at all. So I'm going to stick that into the well, into my tank over there to augment my little... I also have in here, I have my sucker pump still pumping water, and from the upper column, and now that it's not as agitated. So what I'm looking at doing is just sticking that into the well, and then probably going to find myself a nice little CFM blower to get the volume of flow in there, but not the pressure, because we don't need pressure. We only need about 5 to 10 psi, 20 if you really want to have a good flowing pump. But you need more volume of air. The volume is the trick, not the pressure. And you can get pressure in there. Pressure and volume relate, but compressors waste a lot of energy with their pistons trying to give you pressure, and they have very little flow rate. So you want to have volume, flow, less pressure, and that's usually from a centrifugal type, like a squirrel cage blower. And here's my little pump working away, and that's it. Okay, and what you see over here is I've completed a test on I've got a gallon jug over here, and I'm feeding the pipe into my holding tank. I've tested on a very minimum flow rate, minimum pressure, about 5 to 10 psi, very little running of the compressor, just gently bubbling it up. I'm getting about 1 gallon every 2 minutes and 42 seconds, which is kind of a crappy flow rate, but when you do the math on that, that would take about 4.69 days for me to fill my 2,500 gallon tank. But we only use about 500 gallons a day. At 500 gallons a day replenishment, that would take about 22 hours to refill. So in 22 hours, I refill 500 gallons, and in 24 hours, we're using 500 gallons roughly. If we need more, we can turn up the pressure and pump out about 3 to 4 times more of the volume, but this is minimum running of the compressor, so I'm just trying to see how it goes. And so right now I have about 500 gallons per day replenishment from this little system here going into my tank and gushing very weakly, and just a little gush in there every now and then. 0.37 gallons per minute is basically the flow rate, a little over a third a gallon a minute, and that's my 1 gallon test over there. A little dirty water sediment still coming up, but flushing out. And so we're just gonna kind of stick this in here to drop the head on it a little bit. Just lower the height a touch, make it a little easier for the gravity to flow it out. And then, but I want it to be able to fill to the tank. So about there's good. And just close it up, leave it there for now till I poured it in a little better, easier to service. And that's it for now. I'm going to just kind of fiddle with it a little more and go from there, but let my tank fill over the course of a day. I'll show you a working geyser pump. This is a miniature version, a clear see-through, and this is pretty much just an aquarium pump. And then you have over here, this is actually a little bung thing for making your own wine. It goes in 5-gallon drums and it bubbles up the gas. Has a little cap here, it's upside down. So what you have is an outer pipe, your air chamber, and then the inner riser pipe up here. Now over here we have just a little water vase to demonstrate it. What I'm doing is instead on my well pump, what I'm doing is I'm putting the air from the top like that. So I have one bubbler coming into the top and going into the chamber like that, going down, pushing the air, and you'll see the water hammer action a bit. I also have a bubble line going from here down into there, and that makes the water column lighter. And so what happens, but for this demonstration, what we're going to do is we're going to substitute this little air line into here, like this. Okay, so the air line is now just jammed up in there and running from the underneath. And then what you can see is as we come in here and we drop the hammer into here, the pump, what's happening is, now you've got a little bit of the pump vibration going in there. But okay, here we go. So first there's no air being pushed by the water column. Now as we take the second column down, the geyser action starts. Now that's with minimal submergence, that's right at the surface, very little pumping action going on. But you can see the valve starts. Now as I move the valve action down lower, so we have increased our depth of submergence, now we're jetting out water out the top. And you can see up here, quite a bit of bubbling. The deeper you go with it, the more aggressive the bubble action. And this would normally be shooting up a riser pipe. So it's a combination of pressure and volume, and also you're lightening your load on the water column to get it up. But that is your mechanical valving action there. It's substituting for mechanical vanes and kind of a vane pump. Well, the surface tension is also shooting in water. The water that's being sucked up the tube is coming from that meniscus line. So it's being sucked in from the sucker tube there, and then just valve action there. So you get more frequency if you have less pressure, because more pressure is going to push that valve out further. So what you really want is low pressure and wider pipe diameters. The wider you can go, low pressure, high volume of air. And this inner diameter pipe should be as wide as you can make it, And the outer diameter pipe doesn't really need to be as wide, but just a little bit wider. There's an engineering ratio between these two. If we actually went and calculated it, there should be, and you can model it in SolidWorks or Autodesk Inventor, things like that, and determine the optimum spacing between the two circles. You could work it out in math too. And this is your basic geyser pump. So air being built up in the outer chamber and water being shot up as a geyser out the top. And it actually could even be a little undersea propulsion thing if you could keep this emiscus line level, so you'd have to make elbows and you could start moving things underwater like a little squid, a little DARPA type micro submarines, underwater vehicles. So and here, now this is what I initially did in my well. I had the water, when you bubble too fast so that you're not getting anything up the chamber, when you have too much pressure, then the air bubbles are going to start to come outside, and then you get aggressive pumping of the bubbles up your well shaft, and that'll blow your whole water column out and clean your well nicely at times too. So you can use air. Air has a great deal of power and lift behind it, and the magic behind this bubbling action is that the bubbles expand as you go into the depth. So it makes a nice large piston as it's going up the top. You put only in one, and to give you an example, on my well I had about 1 gallon of air put in, and I shot up about 5 gallons of water. All that weight, 5 gallons of water weight, shot up by some 20 feet into the air. Not into the air, but 20 feet from below depth, and then another 3 to 4 feet into the air, 5 feet. But imagine hurling all that power to hurl the weight of, a couple 5-gallon buckets straight up into the air. And that's the power of air. And the kind of hydraulics, pneumatics, actually, in this case. So that's the sucker pump. So what are a couple advantages to this sucker pump, I call it, but a geyser pump and a hybrid air pump, airlift type pump? One of them is that we use less power to pump air, and to pump the water up. We're able to amplify that expansion, the buoyant force, to use that for our pumping action, and to use the nature of water, the air bubbles trying to expand. We're using that for extra power. So we're using nature rather than pushing this mechanical either vane or diaphragm type pump to push water. A side advantage of it is that you're aerating the water, which makes your water well cleaner. It'll tend to agitate like a washing machine the inside of your well, and at first it will suck out sediment from the filter pack inside your aquifer, but then over time it will settle once you have a nice steady pumping rate, and so that way won't ruin your well, but it will wash out the inside of your well. Meanwhile, it sucks up sediment, and where sediment will clog a well pump normally, or jam things, do destruction to the mechanical components like the vanes or the diaphragm, and cavitation is bad because it will cause overheating. Here what you have is just the sediment coming up the well, and it'll go initially into your sediment tank, so you have to drain out your tank a couple times. There's my dog coughing over there. But you have your sediment, and there's someone texting me. So you have your well sediment tank. Your sediment tank, your holding tank normally is what I use, but you get your sediment out of the well, and after time it will stabilize, but you have this constantly clean, aerated well. Then what I'm trying to do next is I'm taking that bubbled air water, the aerated water in the column coming up, and I'm dumping it into my holding tank. And the action of dumping causes, you've got all sorts of agitation of the water. I have, as my boost pump sucks out that water, it's creating a vortex and some motion inside the tank. You want to keep motion inside your holding tank, because that keeps the water clean, so any type of air bubbling is good. Also I have an ozonator in there that bubbles ozone into the tank, but I'm also going to be taking an air line off of the wastewater, not the wastewater, but the outlet pipe that goes into my tank. I'm going to be taking that and then using that air, that waste air that I normally wouldn't use, and using that to either bubble the water in the tank, so it's oxygenated, it'll kill more of the iron and sulfur in there and make it a little more healthy. Then I'm also going to take a little back line from that and take that back into the system, so I'm recycling some of that air. And that'll make it, I'm using less energy. Rather than constantly wasting air, I'm pushing the system a little more. There goes my dog. And anyway, so we have, that's the system I'm looking at using there. But what I'm probably going to do is run a 5-gallon, run my 1-inch line, my outlet line, into my 5-gallon tank. Yeah, saboteur of my video there. The 1-inch pipe comes into a 5-gallon, I'll show you this later, but it comes into a 5-gallon water jug aimed downward, and what I'm doing is I'm putting the outlet onto the walls of the container, and then I'm going to vortex flow that outlet flow into the tank, just because I want to build up a vortex flow in the water. So I have a downward flowing vortex, and then I have an upward flowing vortex out of the suction line that goes into the boost pump, and then recycling some of the air that comes out of there. And that motion of the water, continual motion of the water, continual bubbling, makes like a stream, very clean, healthy water, agitated water, oxygenated water. And that's it. And a good, clean, healthy water in time. Okay, so here we are with my little extra modification on the little bubbler. What it's trying to get a little vortex flow going in here, so it cleans up the water a little better, adds a little energy to the water. Got more aeration going in here, and then up here on this line is going to recycle some of that air. It's hardly worth it, but if I can take some of that back into the system, either for further bubbling or back into the line pressure down in there, it kind of eases my energy costs a little bit. And then up here I just have, that's my air compressor going back there to run it. Up here is just one of those little solar lights, LED there to kind of illuminate it at night. And I like this because then I can see it, I can see the water actually flowing and just check on it once in a while, day or night. And it, get an idea of your flow rates and things like that. So here I'm going to drill out a couple more holes in the bottom of the cap in order to make it a little vortex, try and get it going a little faster. Okay, here we are with my airlift pump, and I'll show you a little bit what we have. We have 5/8 inch garden hose going into 1/2 inch pipe, a large diameter. I'm hooking up a blower to it right now. It's in test with an air compressor. And here's our 3/4 inch line, actually 1 inch line, but 1 inch pipe in here, 2 inch pipe on the, 3/4 inch pipe on the interior, 1 inch pipe up there, and 3/4 all the way on the inside. Drilled holes in the 3/4 are some little pre-holes drilled up here, large holes, little holes, and then as we come down in here, a bunch of little holes down here. Now you want to have about a foot distance from the outlet, or from the inlet, and I had them too low here, so I'm adding on an extension down here with a little 45-degree cut. And that's pretty much it. It pumps pretty well. We just have a couple little repairs to do here, JB weld and things like that. Hokey for the first prototype. So, that's it.